Let's start this discussion of exponential growth using a quick reminder of percentages and multipliers and so on. If I were to say I have a bank account with 10% growth, that's fantastic. I love that bank account. What's going to happen to my $100 if I leave it in my bank account for 1 year at 10% growth? You think, okay, well, that's going to be multiplied by 1.1, and that's going to give me $110. Now, some of you might have thought, well, isn't 10% growth 0.1? That's true. It is, but we're talking growth, so it adds onto the original amount. If you multiply by 0.1, you get $10, not $110, and that would be a pretty crummy bank account. If you were to do this again and take your $110 and leave it in that bank account, because that's a great interest rate, why would you ever change? You get $121 at the end of that year. And then if you keep that amount rolling forward, you see it grows to 133 by the end of the third year. Now, I know there's decimals on that. I don't really care about those for now. You want to keep track of your decimals when you're doing your homework, but for this example, this is enough. The point is, the amount that you're getting paid in interest is growing every year. It's not just $10 a year. It's $10 the first year, then 11, then 12, and it's going to keep getting bigger and bigger. That's the advantage of exponential growth. Now, I have an equation here which I've chosen to write using letters like A, right? A for the growth, P for the principal. Principal is the initial amount in your bank account. And I have this multiplier set up over here that's just ready for 1.1. In this case, of the 10% bank account, that's my growth multiplier. And T is the years of growth, because even though I could write this as my initial principal, which was $100 in my example, times 1.1 times 1.1 times 1.1, who wants to do that? Why wouldn't you just use an exponent instead of saying times 1.1, 1.1, 1.1? Why not just say it like this, 1.1 to the third power? So let's take that idea, and I want to change something up a little bit. I'm now going to write my equation in the following way. A equals P times 1 plus 0.1 to the T. And that makes it very clear that I have a 10% growth. Okay, that 0.1 is in there. It's being added to the 1, and I get 1.1 total as my multiplier. The reason I want to write it that way is because banks a while ago came up with this idea of not just paying you interest once every year. They came up with the idea of paying you interest twice a year. So look at this. Now that 0.1 is getting divided by 2 because it's only over a 6-month interest period or vesting period. And then after 6 months, I pay you interest, boom. And then 6 months later, I pay you more interest, but I'm only going to pay you half the interest each time. Well, that's fine, but we have to capture that by increasing the exponent because we're paying interest more than once a year. Now we're paying interest twice a year. And all the math works out great. This way, you're going to get an answer that's slightly different because we're paying interest more often, and that's better for the person receiving the interest. Now, if you're paying interest to the bank, like a loan on your house or your car, then this is better for the bank. Well, they took it to an extreme. They said, okay, well, what if we just do interest every single month? Now it's 0.1 divided by 12 on the inside of that parentheses. And the higher that number becomes, the more you can squeeze out of this without actually changing what the interest rate is. And what we do is we now call this an equation R over N to indicate that N could be any number of times per year. And I'm just going to keep that N up in the exponent so it balances everything. And that is my exponential growth equation. So advantage goes to the person who can charge interest the most often. That'll maximize the amount they're getting. Now, in the limit, I'll say, what about n going to infinity? You might think, well, that's silly. You can't do interest an infinite number of times. But what if you did? What if you had like a super fast computer and you told it to work on this equation? What you would get from that is basically a whole bunch of calculus, which I am not going to get into. That's a little beyond the scope of this class. But you would find that the number e gets involved here. That thing related to logarithms, it's over on the left side of your calculator usually. And the way we simplify this equation in its continuous form is the following. Okay, that right there is continuous growth or continuous exponential growth.